Since time memorial, mankind has asked itself a question that arouses great fascination. What lies beyond what we know? What exists beyond the limits of our universe? The answer is extremely complicated. Yet the James Webb Space Telescope has discovered something massive and fascinating in the far reaches of the cosmos that could revolutionize physics. What exactly has the James Webb found at the edge of the universe? Why are scientists so excited? We invite you to join us to explore how this telescope has discovered something gigantic at the limits of what we can observe. If you are interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel, be sure to like this video, and turn on the notification bell. Albert Einstein developed the theory of gravity that revolutionized Newton's theory. In 1916, he applied it to the universe. This theory showed that the universe could not stand still and must be in motion, expanding or contracting. In 1929, the astronomer Edwin Hubble observed that the galaxies were moving away as a result of the Big Bang. This is the expansion of the universe, where the distance between galaxies is constantly increasing. Einstein's theory can easily explain an infinitely expanding universe, or one that curves back on itself like the surface of a ball in a higher dimension. Some argue that the universe has an edge since it was born in the Big Bang 13.82 billion years ago. Therefore, we can only observe galaxies whose light has traveled a distance in less than 13.82 billion years to reach us, forming a spatial sphere centered on Earth called the observable universe. In reality, the universe is 92 billion light-years across, and the limit of the observable universe is the cosmic horizon, similar to the horizon of the sea. And we know that there are an infinite number of galaxies beyond it, but their light hasn't yet reached us. Can the James Webb Space Telescope see to the edge of the universe? Being 100 times more powerful than Hubble, it can detect the faintest infrared light from the earliest galaxies in the universe, as well as planets and other stars in their habitability. However, we do not yet know what the telescope will observe when it's pointed toward the edge of the universe. The universe is divided into the observable and the unobservable, with the observable being everything we can see by detecting radiation with our eyes, and the limit of the observable being the cosmic microwave background that was produced 13.8 billion years ago. At that time, the universe was opaque like a dense fog. Some experts believe that there are gravitational waves and neutrinos coming from even more distant places, although this cannot be verified due to the lack of technology. Cosmologists suggest that to better understand the universe, one must consider that what we observe is only a small part of a larger reality. Finding galaxies like Abell 2744Y1, which lies at the farthest edge of the universe, can help us better understand this reality. Although this galaxy is so far away that it takes 13 billion years for its light to reach us, scientists can observe its youth some 650 million years after the Big Bang. The Spitzer, Chandra, and Hubble telescopes work together to discover this galaxy, as each uses different parts of the electromagnetic spectrum to capture data. By combining data from all three telescopes, astronomers connected 7 galaxies that are up to 100 times farther away than any telescope could have observed on its own. Astronomers from the Astrophysics Institute in Canarias and the University of La Laguna used the Hubble Space Telescope to discover the galaxy Abell 2744Y1 and calculate its distance and number of stars using Spitzer equipment. They also used the gravitational lensing technique, which is like a magnifying glass that focuses light from distant galaxies through galaxies closer to Earth. The galaxy is small compared to our Milky Way, with a width of about 2,300 light-years, but its star creation rate is 10 times that of the Milky Way. The redshift of the galaxy Abell 2744Y1 is 8, indicating that its light has been pushed toward redder wavelengths due to the expansion of the universe. Before the discovery of Abell 2744Y1, the farthest known galaxy had a redshift of more than 7, but now astronomers have found something even farther out. A supernova called DES 16C2NM, identified through a dark energy survey. Supernovae are incredibly massive explosions representing the last effort of a star before it dies. To understand how stars work, we must observe their death. Massive stars burn enormous amounts of nuclear material in their core, which generates a large amount of energy. This energy creates pressure that prevents the star from collapsing. When you see a star in the night sky, it is because there is a balance between two opposing forces. Massive stars have a constant struggle between gravity pulling them inward and the energy released by nuclear burning pushing them outward. When the star runs out of fuel, it begins to cool, and the pressure decreases, allowing gravity to take over and cause the star to explode into a supernova. This process happens quickly, in a matter of seconds. When two stars collide, a supernova can also occur. The DES 16C2NM supernova is extremely rare and was discovered in 2016 by a multinational team of astronomers. That star is a type II supernova, which means that it has reached the end of its life and has exploded in a cataclysmic explosion. The explosion is believed to have occurred about 10.5 billion years ago, and light has traveled to us for more than 3/4 of the history of the universe. Due to the expansion of the universe, the supernova is much farther away than it appears to the naked eye. The DES 16C2NM star was particularly interesting because it was a dark supernova, which means that it did not emit much visible light and therefore was difficult to detect. However, it was possible to detect it using telescopes that could see the infrared light emitted by the supernova. A team of scientists involved in the discovery of DES 16C2NM also had the help of 3 powerful telescopes, including the Magellan Telescope and the Keck Observatory. It took 5 years and more than 500 nights of observation to identify this distant supernova, which was a great challenge. However, the team's efforts were worthwhile, as the great distance of the supernova will allow them to better study and understand superluminous supernovae and the causes behind these massive cosmic explosions. A supernova explosion of the magnitude of DES 16C2NM, or any other type II supernova, would have significant consequences for the surrounding galaxy and potentially even for the entire universe. This explosion will release an enormous amount of energy, primarily in the form of neutrinos and photons, which would interact with the surrounding gas and dust to create a shockwave that would travel outward at speeds of thousands of kilometers per second. This shock would cause the surrounding gas and dust to heat up and emit a burst of radiation that would be detectable across a wide range of wavelengths, including visible light, radio waves, and X-rays. In addition to the burst of radiation, the explosion would also create heavy elements like iron, gold, and platinum, which are essential building blocks for planets and life as we know it. These heavy elements would be dispersed into the surrounding galaxy, enriching the gas and dust, and providing raw materials for future generations of stars and planets. Overall, a Type II supernova explosion like DES 16C2NM would have far-reaching consequences for the surrounding universe, and would play a crucial role in shaping the evolution of galaxies over time. Through analysis of the ultraviolet light emitted by the SLSN, scientists can determine the amount of matter produced and the temperature reached in the explosion, which is crucial to better understand these events. A difference between that star and Betelgeuse is their type of supernova explosion. DES 16C2NM is a Type II supernova, which occurs when a massive star runs out of fuel and collapses on itself, causing a catastrophic explosion. Betelgeuse, on the other hand, is expected to eventually become a type II supernova, but it is currently classified as a red supergiant, and it is likely to explode as a type IIP supernova, which is a less powerful and less catastrophic type of supernova. A supernova explosion of the magnitude of DES 16C20M, or any other type II supernova, would have significant consequences for the surrounding galaxy and potentially even for the entire universe. Now experts are looking for other distant supernovae and the ones that are likely to be discovered in the future. What do you think lies beyond the edge of the universe? Let us know in the comments. Remember to like this video, subscribe, and turn on the notification bell. Thank you so much for watching. See you soon.